Welcome back, everybody. Yay, math. Today we're going to jump into chapter 2 and talk about transformations of quadratic functions. Really what we're doing is reviewing what we've done the last two sections, but focusing mainly on quadratic functions. The first form of quadratic function we're going to discuss is vertex form. So we know that the parent function is f of x equals x squared, or y equals x squared. There are many ways that we can write the quadratic function, and the first way that we're going to talk about is vertex form. We call it vertex form because when we have the h and the k, we know the vertex. A reminder that in a parabola, the vertex is this point down here where your graph changes from decreasing to increasing. Or if your graph has reflected, then it changes from increasing to decreasing. So in our vertex formula, A is going to be the stretch or the shrink. We can also have a negative out here for that reflection. H is the x value of the vertex, and k is the y value of the vertex. H is also how far we've moved left or right, and k is how far we've moved up or down. So we're still talking about moving left, right, up, down, stretch, shrink, reflect. It's just in a different format, and we know for certain that the h and the k are the vertex, or where the middle of our parabola is going to be. Let's try a few. If I'm looking at example 1, there's nothing here in front, so there's no reflections, no stretches or shrinks. So this plus 4 means we went left 4, because remember, x's lie in the parentheses. The minus 1 is down 1. That also means the vertex of this parabola is at negative 4. Remember, we went left 4, so it's negative 1. Number 2. Again, nothing here in front of the parenthesis. In here, the parentheses say minus 3, so that means we went right 4. And then we have nothing added or subtracted on the outside. So we did not go up or down anywhere. That means our vertex, if we went right, excuse me, that's a 3, not a 4. We went right 3. So our vertex is at positive 3. And since we didn't move anywhere up or down, we're at 0, because we could technically write a plus 0 on the outside there. Number 3, again, nothing in front right there, so we have no stretch or shrink, no reflection. We have a minus 2 on the inside, so we went right 2. And then on the outside, we have a minus 2 as well, so we went down 2. That means our vertex is at 2, negative 2. Our last example, we again have nothing in between the equals and the front of the x, squared. So we have no reflection, stretch, or shrink. The plus 5 means we went left 5, and the plus 1 is up 1. So our vertex for that is at negative 5, 1. A little review of reflection stretches and shrinks. So remember the negative out in front right after the equal sign is a reflection over the x-axis. So what that means is if our parent function looks like this, the reflection flips it upside down, just like it says. A vertical stretch means that on the outside, again, after the equal sign, but before the x, we have a number that is greater than 1. So this 3 means that our graph, the arms of our parabola, have been stretched. If this is our parent parabola, then we've stretched it closer to the y-axis vertically by 3. The vertical shrink has something between 0 and 1. Remember, the negative in front has nothing to do with stretching or shrinking. Those are flips. So this 1/4 means that if my parent function looks like this, and we've shrunk it by 1/4, it'll now look like this. We're shrinking it vertically towards the x-axis. If you're graphing these by hand, vertical stretches and shrinks means that we're multiplying our y values from our parent function t table, this xy table, so these values right here, by whatever that a value is. So if we were looking at 3x squared, then we'd be multiplying all these y values by 3. If we were looking at the 1/4 x squared, then we'd multiply them all by 1/4. So now we're going to try to put these together and talk about what's happening to each of our graphs. In number 1, so we have a negative here. That means that our graph is going to reflect over the x-axis. This 1/2 is a shrink, and we don't have anything over here to the right of the x that's being added or subtracted. So there's no left, right, or up, down. So if we're not adding anything, that means our vertex is at 0, 0 for that graph. Example number 2, 3x squared. There's no negative, so we are not reflecting. This 3 is a vertical stretch. And again, on the right side of the x, we are not adding or subtracting anything. So that means that we have no left, right, no up, down, and our vertex is still at 0, 0. Example 3, we have this negative, which is a reflection over the x-axis. The 1/4 is a vertical shrink because 1/4 is between 0 and 1. Then over on the right side of the x, we have a subtract 2. Now that subtract 2 is not in parentheses. It's not like number 4 where the x plus 3 is in parentheses. So that means our graph went down 2. But we have no shifting left or right. So our vertex is 0 because there's no left or right, and then -2. Example 4. The negative, again, is a reflect over the x-axis. This +3 is left 3, and the +2 on the outside is up 2. So our vertex is at -3, +2. Here again is our outline that we copied down last section in 2.0b. So this is just a review of how do I write a transformation equation. Number 1 says the graph of g. So that means that we are starting with g of x. Remember, g of x is function notation, and it's just saying I'm a function, I pass the vertical line test. It has a vertical stretch, it has a reflection, and it's going down 3 units. So after the equal sign, according to this right here, reflection comes next. We did reflect it, so we put a negative. Then comes the stretch or shrink, and it's stretched by 2. I don't have any left or right shifting, so we have just x squared. And then down 3 units is -3. So our final equation is g of x is equal to -2x squared minus 3. Example 2. The graph of h. So that means I'm starting with function notation h of x. It says we are reflecting it over the x-axis, going up 4 and left 2. So we do have this reflection. That's the first thing I put. I have no stretch or shrink. I do have a left 2, so we need a parenthesis, x plus 2. Don't forget your squared for the quadratic. And then up 4. Example 3. We have the graph of c. So our function notation starts with c of x. It has a vertex at 3, -7. So h is 3, -7 is k, and then vertically shrunk by a factor of 1/3. So then the only difference between the outline we currently have and vertex form is this area right here where we would have x plus or minus h squared plus or minus k. So we have no reflection. We have a shrink of 1/3. And then our vertex, we need parentheses x, +3. Remember, we write the opposite because x's lie, so it'll be x minus 3 squared. And then -7 for going down 7.